All right, I had you fill out all that stuff and take it down because it lets you be ready to deal with what we're going into today. Today we're learning about inverses of functions. And so the basic idea behind an inverse here is that the inverse is found by just swapping the x and y values. That's really all there is to it. It's a simple idea, but it has some fairly large implications, and it has a lot of characteristics that we're going to need to get to know. So I gave you a table already of f of x so that we could then figure out what the inverse of f of x would look like and what that equation would look like. So we're now going to go ahead and fill in the inverse of f of x table. And yes, that's how we read it. We do not read that as f to the negative 1 of x. So it does not mean like 1 over f of x or anything like that. It actually is specific notation just meaning inverse of. All right, so if it means that we're swapping the x and y values, literally, in order to change this row in this table, I just swap the x and the y values. So it becomes 6, negative 4. That's all we got to do there. And we do the same thing for the rest of it here. So I'm just going to go down the rest of it, swapping my x and y values. The signs stay the same as we do so. The only thing that changes is just the position. Which one is x and which one is y. And now I want to actually take a look and see what each of these graphs would look like, because it's going to tell us something about an original and an inverse and how they're related to each other. So I'm going to go ahead on my first graphing grid and plot all of the points here for f of x. So I'm going to go to negative 4, 6 for starters. Then we go to negative 2, 0. And continue through, just plot each of those points. And that gives us a rough idea about what the original equation would look like, the original graph. I'm not going to worry about drawing in the curve right now, though, because we're just given those points. All right, but now for the inverse function, I'm again going to plot each of those points. So the first point that I plot there is the 6, negative 4. Now when I do this, I had you set up 2 graphing grids. The second one is for later. This is on the same graphing grid. So either use different marks, or better yet, a different color for plotting the inverse points. So for instance, I'm using a different color, but I'll also use a different mark just to make it clear. So 6, negative 4. So I'm going to go over to 6 and go down to negative 4. And so there's my first point for my inverses. I made an X with that instead of a dot, just to kind of keep track of it in case you don't have a different color to use. Mark them differently because I do want to see what they look like on the same grid. All right, continue through the rest of the points for the inverse function. And so we can kind of see what it starts looking like there. Now, there's actually a lot of different relationships that come from the fact that we just switched the x and y. And we're going to start looking into some of those. You'll notice that my first points, if I were kind of visualizing what this looks like, you know, it kind of looks like one of our U-shaped graphs. Kind of looks like a parabola, maybe a quadratic, something like that. If I were looking at how are the points related for the inverse, notice they're fairly similar, but it's like they're on their side, right? Technically, what we're going to be talking about and seeing visually as we go forward is that is actually representing a reflection across the line y equals x. If I draw that in, I'm talking about this line right here. So technically, each of those points is reflected across that line. That's what happens when you swap the x and y coordinates. Is it actually, in terms of a transformation, is a reflection across y equals x like that. Now this actually has some cool implications for later too, because that way if I just give you a graph and say draw the graph of the inverse, you can do it by flipping every single one of those points over that line. But then this at least is a starter for the inverse. We're going to get into some other characteristics here in a little bit, but I don't want to throw everything all just in the first problem. And so the first thing that I want you to put into your notes, because you are going to have a decent number of notes today, because we're learning a new concept here, is just the most basic notes about the inverse equation. Define the inverse equation, swap x and y, then solve for y. So add this to your notes, and then we're going to practice it here in a moment. And so you'll notice that this one is specifically talking about the inverse equation. When we were given a table of values, all we had to do is just swap x and y. That's really the inverse part, is the swapping the x and y. That works for points in a table, that works for points on a graph. It's just that here, since we're talking equations, we're going to have one last step after we swap x and y, and that's actually just solving it for the y value. All right, so we're going to practice that with this equation. So go ahead and write down this equation, y equals x squared plus 1. And we're going to find the inverse equation of this. Now, according to our notes, the first step is to swap x and y. And just like when we did it when we swapped points in the table, all we did was just switch positions. That's all I'm doing here as well. I'm literally just switching the letters, and nothing else is going to change. So my new equation then is going to be x equals y squared plus 1. Technically speaking, that's the inverse. We've done the inverse part. It's just that we really do need to present our final answer in terms of y equals. So now it's just a matter of doing the algebra to get y equals. First thing then, let's get rid of that plus 1. So subtract 1 from both sides. So minus 1 minus 1. On the left-hand side, yeah, all we can do is just make it x minus 1. We can't do anything else to it, can't do anything fancier to it. Just stays x minus 1. Now I'm still trying to solve for y equals, so that means I got to get rid of the squared. In order to get rid of squared, what do I do to both sides? Square root. So we're going to end up taking the square root of both sides. If I can get the pen to work. There we go. Square root x minus 1 equals square root of y squared. But on this line, I know I haven't finished the work yet. We're going to clean it up on the next line. But before I do that, I need to remind you, do you remember that one special rule we have to include when we take the square root of both sides of an equation? Hopefully you do. Hopefully you're thinking, wait, don't we need a plus or minus in front of that? Because we do. When you take the square root of both sides of the equation, remember it has to be plus or minus. Because the negative number squared would also give us the same thing. Alright, and so now I can go ahead and clean that up by taking the square root there. So I end up with plus or minus square root of x minus 1 equals, well, square root of y squared. That's just y. That's why we did square root. And now that it's y equals, we're done. That is our final answer. That is our inverse equation. And that inverse equation is going to have a lot of properties to it, as we're going to see. Now that we've seen how we found that inverse equation, now I again want to go back to the graph, because I'm going to want to see how some of this stuff relates when it comes down to the graph here. So, time to utilize that second graphing grid. On that second graphing grid, I'd like you to please go ahead and graph both the original equation, so the y equals x squared plus 1, and graph its inverse, y equals plus or minus square root x minus 1. Please graph both on the same set of axes. So to check in, you should have those points being plotted for your original equation and more, and then draw the curve in once you've drawn them all in, then go on to the inverse equation. When you've graphed both of those, this is what you should be looking at for both functions. And then we're going to answer these questions off to the left here in a moment. But first, let's make sure you remember how we got those graphs. So the plus 1 here moves it up 1, so that's where I got my first point. And then from there, it's the standard x squared graph, so over 1 up 1, over 2 up 4, over 3 up 9. And then for the square root function, well, the plus or minus just means do it once with the plus and once with the minus. So if I at first just look at it as the square root of x minus 1, then it's a matter of saying, okay, well, the minus 1 tells me to go right 1, and then I go over 1 up 1, and then I go over 4 up 2, and over 9 up 3. Because remember, I'm going over the ones I can actually take the square root of. Notice the pattern is very similar to what we just did on the quadratic, though. Instead of over 2 up 4, we went over 4 up 2. That's because the inverse. That's how inverses behave. And then to finish off the graph here, I did the bottom by just then accounting for the negative part of the equation. All right, so we can see what the graphs look like. And now we can start answering some questions about these, seeing some different properties about the original and its inverse in this case. First up, the first question we're asked is, are both of those functions? Are they both functions? No, they aren't. The first one, in blue, the original equation, is that a function? Think vertical line test. Can I draw a vertical line through it anywhere and hit it more than once? No. And so that one is a function for that reason. But the inverse, the second function we graphed, our square root here, notice that vertical line hits it in 2 places. That means it's not a function. Because remember, for it to be a function, we can have no more than one y value for any given x. So while the original is a function, the inverse is not necessarily a function. Sometimes it will be, sometimes it won't be. All right, and then domain and range. Well, what's the domain of the original? That's the blue one up there, the x squared plus 1. What's the domain of that? Well, it's the same domain as it is for all quadratic functions. It is all real numbers. Okay, what about the range? Is the range all real numbers for the original? Well, if I'm looking at my original function up here, it doesn't go down forever. It only goes down to 1. So no, it's not going to be all real numbers. It's only going to include the y values that are above or equal to, technically, 1. And so my range here, y is greater than or equal to 1. Now let's do the same thing for the inverse. The domain of the inverse. Is that all real numbers? Well, it looks like it starts there and then goes to the right. It doesn't include anything to the left of that point, so it's not going to be all real numbers. My x values are only going to be greater than or equal to 1. Because you notice they start at 1 and then they go to the right from there. What about the range on my inverse? Well, I know it goes off the grid so we can't see. Let's anticipate those. I'm going up here. Does it keep going up forever? Yeah. How about when it goes down? Does it keep going down forever? Yeah. And so what do we say our range is? Our real numbers. Do you notice anything about those? Remember that the inverse, our basic idea of and definition of what an inverse is it swaps the x and y. Domain and range are descriptions of x and y. So yes, it also swaps these. So you notice my original range became my new domain. Except, of course, instead of y, we're talking about the x value, so it's x instead. And my original domain became my new range. And again, the x and y's, the letters would switch there as I switch them, if it weren't all real numbers. Next up then, now that we've seen the inverse in action, it's time to actually formalize some notes on things that we might have observed along the way. So all of this now needs to be added into your notes. So one of the things that comes up in there is talking about the original and inverse both being reflected across that line y equals x. Here I've actually drawn that in again for you so you can visually see where that line appears. Again, this line y equals x, and by the way, do you see why this is the graph of y equals x? Like the equation y equals x here, that's y equals a line, because it's just plain old x, slope of 1, y-intercept is 0, so that's why that's our equation. and y, that's our line. And so if I take each of the points and actually flip them across that, so for instance, I'll grab this one up here. If I take that point and reflect it across that line, I get to my new point. Notice by reflecting across that line, that means it's going perpendicular to that line, so we're going straight across it. And we're going the same distance on both sides. And so, should I give you a graph and just say, hey, graph the inverse? And even if you don't know the equations, you can still do it that way if you end up needing to.